Welcome back to Dystopian Bot Rise, where we uncover the mesmerizing industrial processes that transform raw nature into everyday culinary essentials. The humble tamarind fruit, known for its distinct sour flavor, begins its long journey high up in the branches of these trees. Harvested in massive quantities, these fruits are transported by the ton to industrial facilities designed to process them with extreme efficiency. Upon arrival, the raw materials are unloaded into the receiving bay, marking the very first step of this complex automated transformation. Heavy-duty conveyor belts immediately take over, carrying the raw pods upward to begin the rigorous initial stages of cleaning and preparation. Powerful air blowers are utilized to remove light debris, such as dust and dried leaves, ensuring only the fruit moves forward. The outer shell of the tamarind is brittle but tough, requiring specialized mechanical force to crack without damaging the precious pulp inside. Precision rollers apply calculated pressure to the pods, cracking the hard exterior shells while keeping the inner fruit structure largely intact. Vibrating sieves then shake the mixture violently, allowing the broken shell fragments to fall away, leaving behind the valuable fruit pulp. Quality control is essential at this stage, ensuring that any spoiled or discolored fruits are removed before they contaminate the batch. The shelled fruit is then guided into massive stainless steel washing tanks, where the next phase of deep cleaning officially begins. Turbulent water jets and air bubbles scrub the sticky surface of the tamarind, dislodging any remaining sand or fine dust particles. Rotating drum washers provide a second cycle of cleaning, tumbling the fruit under high-pressure sprays to ensure absolute purity and hygiene. Emerging from the wash, the tamarind pulp is now glistening and clean, ready for the difficult task of seed and fiber separation. However, the process is far from over, as hard seeds and tough fibers are still embedded deep within the soft flesh. Specialized de-seeding machines use friction and blunt agitators to loosen the bond between the sticky pulp and the hard internal seeds. The shiny black seeds are effectively ejected into a separate waste stream, often collected for other industrial uses or byproduct processing. What remains is a rough, fibrous mass of tamarind flesh, now free of hard contaminants, but still requiring significant refinement and processing. To remove the tough fibers, the pulp is fed into high-speed centrifuges that use centrifugal force to pull the fibers apart. Internal screens catch the long, stringy fibers, while automated wipers scrape them away to prevent clogging the delicate machinery downstream. As the tamarind pulp is now significantly smoother, having shed its hard shell, seeds, and tough fibers, ready for thermal processing, we now enter the heart of the factory, the cooking hall, lined with massive steam-jacketed kettles designed for precise thermal treatment. The prepared pulp is pumped directly into these giant vats, where the chemistry of heat will unlock the full potential of flavor. Purified water is added in exact proportions, a critical step to ensure the final paste achieves the perfect viscosity and texture. Massive mechanical agitators begin to rotate slowly, folding the mixture continuously to ensure even heat distribution and prevent any scorching. As the temperature rises, steam begins to billow from the vats, signaling that the extraction and sterilization process is well underway. Advanced sensors monitor the temperature in real time, maintaining a specific heat range to maximize extraction without degrading the natural nutrients. As the mixture simmers gently, breaking down the cellular structure of the fruit to release the signature sourness and rich aroma. Over time, the color deepens significantly, transforming into a rich, dark hue that indicates the full development of the tamarind profile. Technicians periodically draw samples from the vats, visually inspecting the breakdown of the pulp to ensure the cooking cycle is complete. Once cooked to perfection, the hot mixture is pumped out through a network of insulated pipes, heading towards the filtration stage. The next challenge is texture. So the paste is forced through a series of microfilters designed to catch microscopic impurities. Passing through these fine screens, the paste is stripped of any remaining grit or tiny fibers, achieving a velvet-like smoothness. High-pressure pumps work tirelessly to force the viscous liquid through the resistance of the filters, ensuring a consistent output flow. The result is a concentrated paste that cascades into the holding tanks, displaying a perfect uniformity that manual processing could never achieve. Never. To intensify the flavor and extend shelf life, the paste enters vacuum evaporators, which remove excess water without using high heat. This gentle evaporation process preserves the delicate volatile compounds of the tamarind while achieving the specific thickness required for the product. Automated sensors constantly measure the brix level, a standard unit for concentration, ensuring every batch meets the exact same specifications. The paste is now thick, heavy, and potent, moving slowly through the system as it prepares for the final stage of packaging. Before it can be packaged, the paste must be cooled down rapidly in heat exchangers to prevent overcooking and preserve color. We now enter the sterile filling room, a controlled environment where hygiene is paramount to prevent any contamination of the final product. And thousands of empty jars march in perfect unison along the conveyor lines, waiting to be filled with the concentrated tamarind paste. Before filling, each container is blasted with sterile air and bathed in UV light to eliminate any potential microscopic biological threats. High-speed nozzles descend with robotic precision, dispensing the exact weight of product into each jar without spilling a single drop. The filled jars move immediately to the capping station, minimizing the time the product is exposed to the open-air environment. Rotary cappers apply the lids with calibrated torque, creating an airtight seal that locks in freshness and prevents leaks during transport. Automated labelers wrap the containers in colorful branding, providing consumers with nutritional information and giving the product its commercial identity. Lasers or inkjet printers rapidly mark each unit with a batch code and expiration date, ensuring full traceability for safety compliance. These computer vision systems inspect every single jar passing by, instantly rejecting any unit with a crooked label or improper seal. For consumer safety, the finished products pass through metal detectors and X-ray scanners to guarantee no foreign objects are inside. Robotic arms, tireless and precise, pick up multiple jars simultaneously and place them gently into cardboard boxes for final distribution. The boxes are automatically folded and taped shut, ready to withstand the rigors of shipping to supermarkets and kitchens worldwide. Heavy-duty palletizer robots stack the boxes onto wooden pallets, building stable structures that maximize space for storage and logistics transport. Forklifts whisk the completed pallets away to the warehouse, where they await distribution to satisfy the global demand for tamarind. From a rough pod on a tree to a refined product on the shelf, this jar represents the pinnacle of processing. Yet chefs and home cooks rely on this consistent paste to create authentic dishes like sour soups, sauces, and refreshing beverages. Its versatility extends to dipping sauces and marinades, where the concentrated acidity balances perfectly with sugar, chili, and savory spices. This facility stands as a testament to modern food engineering, capable of processing massive harvests with speed and impeccable hygiene standards. The gleaming steel and rhythmic motion of the machinery are not just functional. They are the artistry of the industrial age. Behind the scenes, the laboratory team continues to monitor samples, ensuring that safety remains the absolute priority until the very end. Responsible manufacturing also involves treating wastewater and managing byproducts, minimizing the environmental footprint of this large-scale industrial operation. Even the waste is valuable. Even the shells and seeds are often repurposed as biomass fuel or organic fertilizer for the next harvest. As we pull back, we see how this facility connects the agricultural efforts of farmers with the dining tables of consumers. It all starts with the farmer, but it is the machine that ensures their hard work reaches millions without spoiling. From the violent scrubbing of the wash drums to the gentle filling of the jars, every step is perfectly synchronized. The smooth, dark paste is a triumph of consistency, a standard that has changed how we cook and consume tamarind globally. Where manual processing was once laborious and inconsistent, industrial automation now provides a solution that is fast, clean, and reliable. The logistics network takes over now, carrying these boxes across oceans and borders to bring this unique flavor to the world. Global demand for tamarind paste continues to grow, driven by the popularity of Asian and Latin American cuisines in international markets. There is a strange beauty in these industrial spaces, and a quiet power in the steam and steel that feeds the population. The conveyors never truly stop, a relentless cycle of production that mirrors the insatiable appetite of the modern consumer market. Seen from the inside, the machine is a protector of quality, a rigid framework designed to eliminate error and variability. Keeping this beast running requires a dedicated team of engineers who maintain the intricate mechanical systems day and night. Behind the heavy steel lies delicate circuitry and code, the invisible intelligence that orchestrates every movement within this massive facility. The transformation is complete. The raw, messy fruit has been tamed and packaged into a form that is convenient for everyone. When you twist that cap and hear the seal pop, you are connecting with this vast, complex chain of industrial events. A single spoonful contains the essence of dozens of pods, concentrated and refined to deliver maximum flavor with zero waste. It dissolves instantly in hot water, releasing that tart, fruity aroma that is the foundation of so many beloved traditional recipes. Ultimately, this technology serves a human purpose, bringing families together around the dinner table to enjoy delicious, high-quality meals. As we leave the factory floor, we appreciate the incredible scale of engineering required to keep our pantries stocked and ready. The trucks depart into the sunset, carrying the finished goods to distribution centers, completing the daily cycle of industrial production. We have witnessed a journey that bridges the gap between the wild, natural world and the precise, controlled world of automation. Industrial food processing often gets overlooked, but it is the key to convenience, safety, and food security in our modern era. And it is fascinating to think that such a simple, rough-shelled fruit can undergo such a sophisticated metamorphosis within just a few hours. Through rigorous cleaning, high-temperature cooking, and sterile packaging, the industry ensures that what we eat is both delicious and safe. There are countless other ingredients with equally complex journeys, waiting to be discovered inside the hidden world of industrial manufacturing. Next time you use a jar of tamarind paste, take a moment to appreciate the science and engineering that made it possible. If you enjoyed this deep dive into the tamarind production process, please hit the like button and subscribe to our channel. Let us know in the comments below which industrial food process you would like us to explore in our next documentary video. Thank you for watching Dystopian Bot Rise. Stay curious, stay informed, and we will see you in the next mechanical adventure.